We're just gonna continue from where I stopped yesterday. Puts block here. Taking a long time to start. Finally. I'm gonna press a 5 until I get to the points that I think I was yesterday. Because I'm pretty sure I've read the comments there on the struct. I think it's this struct here that it says that uh, the vector that I thought it was the vector that they use to create the Bezier curve is probably the one that they use because of the description that they put on the comments there. So it's made out of 3 points and is I think it's kind of like a matrix because a vector of vectors. So the first one is the source point. The second vector is the control point in the middle. Not necessarily in the middle because I don't know what's going to be the position. And the other one is the target. So think this was a function that I wanted to step into next time or last time. I'm just gonna press F5. I think I have to get to the point where it opens the GUI and then I have to interact with the GUI so that when I press the button there, it stops at the same point that I was at yesterday. I'm probably gonna have to remove this layer. It's one of those things that probably all of the geometries used. So I think I put these breakpoints last time, so I wanted to, because I wanted to step into them, because this one is dependent on the data that they have on this area and the type. But now I think it's probably better to remove this. And I think this layer is probably something that all the objects are gonna have. That's the reason why it's going over all the time. So I'm gonna remove. So I'm gonna add again. Curve Bezier. I think if I press F5, probably is gonna go to the right place. So yeah, I'm just gonna press F5. So this one I remember is just changing the position, and I think is this one that's creating. And this one is the one that has the stuff that I want to see. So in the comments on this thing here, it says the description here. Keyframes on F curves allows code reuse of Bezier eval code. In points on Bezier curves, paths are generally base triples. I think this is one of the other one. I don't remember really well. Uh, DNA curve times triple. So location of handle 1 is vector 0. Location of control points, the middle one, and the location of handle 2 is the second one. So I think by default it's going to be that curve that shows there that has only 3 points and is using this vector here. So I think that this is the main thing. And so I have to think about how I'm going to do this. So yeah, I was thinking about creating another uh, maybe I should do it on this file here and just do it after this stuff. So let me think about it. It might be better to I'm going to separate into another file. So blender curve probably other Then I'm gonna copy the stuff that they have there. I need to figure out a way to extract the information and then try to test on Godot. So I'm just gonna copy the thing for now. And then I'm going to look into the function there based on the flow of execution to see how it's changing this vector. Because I think the vector is the main thing that it's going to use. Is this vector here to create the curve. And then I have to see, I'm going to put more breakpoints. I'm probably going to have to, I'm going to step over like the whole cycle until it gets back to the GUI to making it work there. Then once I do that, I'm gonna look for the other breakpoints that are. I think I already put the breakpoints there, but I'm gonna look for it again, which is the stuff, the functionality that adds the depth to the curve. So it's gonna be based on this ner. It's gonna. I think the other stuff doesn't matter that much because I'm gonna have to extract everything anyway. So I'm gonna put. I have to see. So I'm gonna take one step at a time, obviously. So the first part is just getting the initial curve and then putting depth. And then the other part is figuring out the functionality of how they add other control points, which is probably gonna be on this back here as well. So I have to figure this out. So it starts off like this. So I think I'm gonna copy all the information that's used here on here. Oh, actually, on the other one. I'm gonna copy here. Only the stuff that is related to the vector there. It's gonna be, yeah, it's probably easier to just copy this stuff here. And this. And then see what is missing. I have to see if this is the one that it actually goes through. It's better to just step over, but I'm pretty sure this is probably going to be a switch statement with all types of curves that it has there. So it doesn't matter that much, but obviously it's better if I get the one that is being used there. So it's also important. And like probably the easiest way is just to copy the whatever functions they use instead of trying to figure out. I might have to figure out though. But if they just do it based on the like square brackets operator, then I think I can, because the vector tree on Godot has the overloaded stuff functionality to access the points on the vector or to access the index of the vectors. So I think what I can do is just copy the functions that they use and put it on the other thing there. Instead of trying to figure out how to convert or the equivalent. But maybe it's not that hard actually. If it's just multiplication and stuff like that, it's probably gonna be easier. So it is the first one. So I want to copy everything that they have related to this. It's probably gonna be up to here. Let's see if this. I think I'm gonna have to copy this because it is related to the points here. But I'm not really sure. I don't know if this is for different curves. What's going on here? Because they're probably linked through a linked list. So this might be related to the points on the other curves, but I'm gonna try to do without all this stuff here. Yeah, smart. Let's copy the thing there. I don't say that understand the problem. I suppose should be working here. Or it's because I'm reassigning. I think. Maybe not it's not that bad. Or it doesn't make sense actually because this is supposed to be accessing from here. So I don't understand why it's not working here. Maybe something related to the type daf here, but I need to review type daf because I don't understand why people use it sometimes. Maybe it's because I'm not allocating memory there, but or it could be some compiler stuff or IntelliSense stuff. So it's multiplying a matrix of 4 with a vector of 3. If I need to put this. The annoying part about this is the stuff that I was saying. Is that I might have to create or to use Transform 3D, I think. Transform 3D, I think, is a 4x4 matrix that Gora uses, if I remember. So I might have to change this so that it works with a Transform 3D, and then I pass this vector here. And then I use a vector of vector trees. But it is kind of annoying because you have to like figure out here the indexes and how I can translate this. So I guess if Transform 3D doesn't have this function, I can just copy there and then just change the way that I copy from the other functions that are similar to this one, and then I just change the indexes. But it is kind of annoying to do these kinds of things. And this part here, I'm not really sure if I need to. What's there? Yeah, but I think in the beginning it's just gonna be this. So what is value? Is one in the beginning. I was expecting more like an equation, a function that has an equation, because I think Bezier curves are, Bezier curves, I'm pretty sure it's just equations, polynomial equations, and I think there's mathematical tricks you can do to you multiply one point with the other and whatever, and you build the equation based on like the composed parts of the different points. So I was expecting something along those lines. So A is true. Hmm. Yeah, I might have to copy this. Number of points in the U or V directions. In this, UV coordinates are used to put textures on surfaces. So the way it's very complicated actually. There's a keyword that's called perspective divide that you can find some videos on YouTube that are very helpful to clarify. Because there's a problem with the perspective on the way that the thing is going to be rendered and how the coordinates from the texture are going to translate into the surface. So the coordinates from the texture, I think they go from 0 to 1, if I remember correctly. And that's the coordinates you use on the shader. And then there's a function on the shader, which is the simpler function, which is going to take those coordinates and is going to transfer that into the pixel of the actual shape in the visualization. So, and then usually on OpenGL, and I think on Vulkan too, probably, but I know that OpenGL has, Vulkan also has, I remember looking into this as well. Uh, Based on different filters you put there, is gonna, if the texture coordinates don't hit the limit, let's say, of the shape, then you can specify what's gonna happen. So either the same image is gonna be reproduced at different parts, or something else, or it's gonna like fill the edges or whatever. And to get the coordinates correctly is very annoying because you're sending points one by one, and then what the framework is gonna do is gonna interpolate the points you pass. So, and this is why everything is rendered with a triangle, because you need more points to make sense of what's going to happen between the gradient. So, like one point that you're passing is on one side, the other point is on another side. And then based on the equations that they use, they get the minimum values. In the case of normal points, it's like you're interpolating the 2 points, and then you're using this mathematical equation, which is basically the distance from the current point pixel between the 2 points that is being drawn, and you're using that to determine the colors of the pixel. But in case of the texture, you're using the UV coordinates instead, which is just the texture coordinates. I'm pretty sure the UV is texture, but I don't remember. Like it's the standard way to say it is texture, but I don't remember really well. It might be another name. Yeah, it's UV. So I had this image here. That's basically what's going on. So I think those points there that I'm looking at and that the function has is the stuff related, the information related to the UV coordinates of the thing. So in case you want to create a tube that is going to accept a texture, for example, you're going to need that information, I think. So it's direction of UV coordinates. And this video here is very good. Respect to projection, texture mapping. But yeah, so it's gonna be annoying, I think. I have to copy this. I I'm trying to think about the easiest way possible to do this stuff. It might be just a lot easier to just copy everything and put his lap on the header there and just use the functions from other classes that are gonna be from Godot. So I can like basically use the same structure and then instead of allocating memory if the stuff that they use to allocate there, just use memnew from Godot. And that's probably I think I'm gonna approach it in the same way that I think is best to approach algorithms. Just do a breakforce solution first, so you have something, and then over time you make it better. So I think that's probably the most productive way to go about doing this. So I'm gonna have to figure out why the pointer is not working there, but I think it's because of memory. So I guess I can try to put memnew there. So I'm gonna have to go back on the other function and copy the rest of the thing here. Maybe I should do. So let me think about it. What is the best way to do this? The other one is lap, like puts a bunch of things on the same file and then gets very confusing. Maybe that's the easiest way to do this now. I'm gonna create a folder. So I'm gonna slowly transfer this stuff from Blender to this. And I'm not gonna incorporate this on the other stuff. We're just gonna paste the functions here. And then over time, so I'm gonna use the shoe files to organize everything. Once I have like a clear picture of how everything works. So the main goal is to create one function, I think, only, and then use all the stuff that they use to build the curve on only. So like the function is gonna be the interface to create the curve, I think, and then I can transfer this structs into the file or into the class, go to a class that I have there. I'm gonna put. So I'm gonna put the functions and maybe the enums is better to put here. And maybe we should do just a header and a C++ file. And then just just puts the functions here, or the structs and the declarations here, and the definitions there. And then gonna put this on another function. but I'm not gonna use this file probably. Yeah, that's probably the best idea. So I copy everything in exactly the same way that they do there, all the structures and all the functions involved. Then over time, I just restructure everything into one thing. I'm gonna have an entry point function. There's gonna be so build 3D curve. Don't remember if I need to put here. So I'm gonna put all this stuff there. There we go. So I'm probably gonna have to. I think I'm just gonna press F5, go back, and then I copy everything. Otherwise, or maybe I just go. I'm gonna go with F10 until I get to the point. Then I'm gonna do another round to clarify everything. Yeah. So basically, get everything, then later figure out. So here, just checking if it is a circle or not. And if it is, gonna make it the next equal to this one. So it's like creating circular linked list, I think. And if it isn't, it just goes to the next point. So does this overload the... It doesn't overload anything. So how does it work? I guess it's because it's a pointer. So because it's a pointer, works like it might be in the way that they allocate memory there. So just increasing the index when you do plus plus. I'm not 100% sure, but I think that's what's happening. So here, just going to the next spot on the pointer here, which comes from here, which was the one initialized on the other function. So this is the main one, the Bezier curve that it creates there in the beginning, and it has this previous and next, because it creates this linked list. The next is just the after, and the previous depends on the shape. So is there a new pointer, or it's gonna be plus a minus 1. So it's going to be the last one of the thing. And then this other function is probably the one that, so it takes the three different points on the list, so the current, previous, and next, and it does these calculations here. This is multiplying by 2. So P2 is the control point, I think. What is P3? 3 is the next. So it's getting the difference between the two different points and multiplying by 2, and then starting on this pointer, on this PT here. And then makes P1 equals that. 0.1. And 2. So it's gonna change here. The weird thing is that it's not doing anything here. Must be these two things here. This picture. It's gonna be online to find this. I think I'm just gonna skip or just go over fast this one, because I don't need to understand the nuances of that. And it's kind of annoying to understand what is going on there, but it's basically manipulating the like doing some calculations based on the. I'm not 100% sure what the linked list. I think the linked list is just extra data that the curve is gonna have. So it's not directly the same points that it uses in there in the beginning, which is the points from the back tree, but it's indirectly using those points to build this extra data for each point. That is gonna be the UV stuff related. So it connects the points through it creates these three different points, which it creates this linked list based on what kind of curve it's going to be, if it is going to be a curve, or if it's going to be a circle or the other Bezier curves that it has there. And then it does some calculations to store on that struct there that holds the information for the curve. It does calculations to store the UV stuff related to the curve. It doesn't matter that much to me. I don't want to spend a bunch of time understanding nuances, but it would be nice if I could find the, because I think the thing is going to the wrong place there, VS Code. I think that the Pichu is probably a macro. If I search for define Pichu, oh yeah, doesn't show anything here. I want to understand what the Pichu here is, because I think these are the final values that it changes there, but I think it's going to the wrong place when I put F12 here, because I don't think that this is related. It's just some other stuff. So they probably defined Pichu somewhere. Or maybe it is that place, and it's just something that I don't understand what's going on here. Because the weird thing is that here, there's Pichu as well. Whatever, I'm just gonna keep going. Just use the control points of the curve to build these points here, and then does a bunch of calculations, and then it's gonna store this on the other values inside of the same struct that they use to create the vector there. Oh, the tree linked list is from the main struct here. I'm gonna have to copy everything, I think. So copy this stuff in the beginning. Hmm. So probably the best way to do this is to just comment out this stuff and then wait to see if it's gonna be necessary. So I want to remove as many things as possible and just use what is necessary to create the curve. Hey, what's up? ROS memory age. There we go. I'm not sure what you mean by that, but thank you. If it is a good thing. I think it is because of the symbol you're putting there, but I'm not sure. Like the thing that I'm thinking about here is that like when was trying to make that tax work on I was just trying to make tax work in general to with the minimum amount of dependencies as possible. I was looking for I looked into all these other libraries and I was trying to figure out and then I think the one that I was trying to translate, I don't remember if it was the first one. I think it was the second library I was trying to translate into my own code. I went through a similar process that I'm going through now, and it was from NanoVG library. But the issue was that like everything depends on a bunch of other things that depend on a bunch of other things. So it became kind of annoying because in order to make it work, I had to copy a bunch of different structs and enums and stuff like that. So, and then later on, what ended up happening is that I had to. I went a different route basically, but I was basically the same thing here that I'm at now. Is like how much of this stuff do I actually need to put, or and how much of this stuff can I just use from the stuff that I already have, that is from Godot. So like one of my concerns here that I'm thinking about now is like these kinds of things here. So, but I'm not 100% sure which way is the best to go about it. Like, I'm thinking that it's probably better to just like comment everything out and then try to do it only from the stuff that matters. But I'm not 100% sure. Subscribed and I have to check out your channel. It's interesting. Doesn't work. Oh, okay. Thank you, man. So the type here, I think it doesn't matter. This as type they curve types is just gonna be on the thing there. Unless like because the way that I'm thinking about doing is not gonna be like this, but maybe I should do it this way. The way that I'm thinking about it is just one curve, because I don't want to overcomplicate things. Just want to make it simple as possible. And the goal of what I'm doing is not the same goal that they had. So like the way that I'm thinking about it is just creating one class that is gonna handle like one type of curve, and it's just gonna the difference on the curve is gonna be based on the control points. And I'm gonna add. I think I can make it possible to be able to add the control points from the editor by subscribing the property from the class into the editor, but basically it's going to be the same logic. So it's going to be a vector of points, and then based on the points, I do the calculation on a function. So I think this types here doesn't make a lot of sense. So I'm just gonna, I'm gonna remove, so I'm gonna try to remove as many things as possible. And then if I need it, then I'll see. The issue with this is that obviously the more things I add, the more complicated it might be to like remember the stuff that I removed or not, and then like I might have to waste a bunch of time figuring out. So, but I think it's worth to risk Just trying to remove all this stuff that I don't think it matters. So yeah, let me copy the function here. So this select is also another thing. Because the video I was just watching there on YouTube that they were explaining some things about the animation because they use the same Bezier curve for animations that they use to actually build the like if you want to build the geometry based on curve it's going to be like the underlying data is going to be the same probably the because animations all that an animation is just a Bezier curve that interpolates the values you can use the Bezier curve to interpolate whatever values in order to create the animation over the frames. That's how it works, I think. So this selection here, I think, is related to this kind of stuff. Is to check whether or not the object is selected or something. But I think for my stuff there, I'm not really sure if it makes sense to I leave this stuff there. Since it probably makes more sense to remove and then to just change the other function as well. Yeah. So I'm gonna look into this one. I'm gonna remove from the other one. Cause maybe it's gonna fuck me up later, but I'm gonna I think it's good anyway because it's gonna force me to like study this stuff. This part's gonna be annoying though, because I don't have the. How can I figure out? Or maybe it's on the other function. Because I'm gonna have to figure out where they define the P2 there, and just search a generic name that is kind of hard to. So this one is for the circular one, like it sounds. I'm just gonna put no here, which means I don't need to put this stuff at all, I think. Because here, okay, let's say, no, I think I do need I need the other one, but not this. Uh, I'm going to be right back. I got some tea. Yeah, this is the annoying part doing all this stuff here. So I'm gonna ask ChatGPT see if it knows. Just let me see if I can remove this. So first I'm gonna ask ChatGPT what this is about. Not very helpful. I'm gonna add this stuff again because I thought it was related to the stuff being passed there as an argument. But I think it's just another enum, so I'm gonna copy because probably all the other enums that are used here come from the other enum, and I don't wanna rethink everything. It's gonna be this here probably. No, I'm just gonna look for it. Now that I'm thinking about it, that I'm copying this, I've seen a video where they talk about that usually, like, people that work with this kind of stuff, they use other software than they use Maya, which is another software, rather than Blender, which is like the paid version, which is supposed to be. It seems that it's better than Blender. And I think he was saying something along on one of the videos. Someone is saying that something along the lines that they create this pipeline that I'm creating now, where they build this stuff on one software and then they bring to Unreal Engine. So apparently Unreal Engine has a pipeline like this, and probably Unity has too. So maybe it will be a good idea to just copy everything, like instead of doing what I'm doing now. Because what I'm doing now is just I'm just gonna use these codes. Because initially, what I was thinking about is just to like create the function that is gonna create the Bezier curve. But the more that I think about it, the more I think it makes some more sense to, because both is gonna be easier, I think. It's gonna be both easier and it's gonna allow me to have a lot more stuff that I might eventually need from Blender. But I'm not 100% sure if it makes sense to do this. Because if I do this, then I think it changes what I'm doing here now. Because I don't think I'm gonna use these files. I'm just copy and pasting everything here. So that makes it easier to think about. And then I was thinking about creating only one function and simplifying, or maybe I keep the structs that they use and the enums and stuff like that on a header, and then I use that. And maybe I do keep all the files and then I just use the struct as the interface, and I put, for example, this nerb here instead of the other class that I have there, which is the line 3D mesh. I think that's probably like the best way to go about it, because then I don't have to spend a bunch of time understanding. But obviously then like it would be part of my module. So the other thing that I can do is just create another folder on the top of the of Godot's codes, and then just put like Blender folder, and then just copy everything from there. I think maybe that's probably a better idea. Then it would allow me to just like put everything. It would be more organized and it would be a lot easier to translate the information, I think. All I have to do is just find the classes that matter. But the main thing that I'm not sure is like it's gonna be I, because I don't care that much about maintaining Godot's logic, let's say, of having everything on the object-oriented paradigm of. But I'm not really sure if that is gonna cause problems, because probably the way that they do it on Blender is by using the context there. So all these classes and stuff's gonna be related to the context, and well, maybe I can create the I can reuse as much stuff as possible, and then just try to keep it like encapsulated by whatever functionality is necessary to create the data, the vertices, and then just leave everything else out, or try to do it in this way. It might be a better idea, I think. So I'm gonna do like this. So I'm gonna put it on another. So what I'm gonna do is just like as I'm doing, instead of doing this stuff here on the folder that I'm doing, which is on my module, I'm going to create another folder and put these files on that folder. And then I'm just gonna copy as much code as possible, so I don't have to think about stuff. And if it's necessary, then like I can create a funnel like that. So I put on that folder first, then I try. So if I'm able to make this happen with the line 3D using the stuff there, then I think about, then it's already gonna be set up if I want to. Like all you have to do is put on the sconstruct file on the build system of Godot. You just put SQL script and then you copy the way that they do it on the other subfolders to compile the C++ and headers. I think that makes more sense. So I'm gonna do another folder on the top. The only thing that is kind of that I'm not sure how to go about it is that obviously it's like a different paradigm, but I don't know if it matters that much because, like I said, there's always a trade-off between. I'm just gonna put Blender. There's a trade-off between efficiency and time, and developing time. So I think this way is probably gonna work. Like I can use the structs as an interface between Blender and Godot, then just use mem_new to allocate everything. This mouse is kind of fucked. So maybe we should create another file here. Hmm. Let me think about this. I'm contemplating because obviously they didn't do it. So I'm wondering why people don't do this. It's obviously not ideal because of the like it's different paradigms. So Blender uses one paradigm and the code is gonna be designed in such a way it's gonna work for their stuff, the way that they manage data and the way that they update everything. But I'm not seeing the problem with because if the purpose of what I have there is just to build the vertices and then I use the vertices on the array mesh, I think it doesn't matter that much. All that matters is that I have the interface, I have all these structs and all this other stuff that they use when it comes to managing the actual uh, structures that are gonna manage the data, manage the construction of the vertices. So if I have that, then I can use that on the other Godot classes to incorporate this stuff. And the reason why I'm thinking about this now is because obviously I want to do the least amount of work for the most highest amount of reward. I think that makes sense to think about it this way. So like instead of copying one stuff by one, I can just look at the files that they use and then just copy the files straight up. Like just copy the whole thing everything that they use, all the files, and put there on the Blender thing. And then I can see if I can include that on Godot. And I don't see why. The thing that is kind of concerning me about this is because like I think that the people that created Godot are very intelligent. So like I'm wondering why they didn't do this before. And there's probably a reason for it. So it's quite the reason why I'm kind of hesitant to do this. So maybe what I should do is just test. So, 'cause the thing is, obviously, I don't want to copy everything. I just want to copy stuff related to. So, but I'm not really sure if I should do it, if I should do a new file structure there. I think I'm gonna do that. So it makes more. But the problem is, so the question I have now in my mind is which one is better? Like, should I slowly, should like just copy the stuff that I need, or just copy everything and then remove? Because now what I'm doing is just incrementally adding the functions. So the way that I was thinking about it just before streaming today is that like I copy paste the functions. Wasn't even thinking about it that way. I was just thinking about I'm gonna get the functionality from the functions. Then I put everything on a header file. It's gonna help me like organize, see sequentially how it's created. Then after I have everything on a header, I can put everything on a function or a couple of different functions to just have the functionality that takes the points and builds the data for the vertices. And then I test that on the other class. But then I thought about this, like just copying this stuff because it's easier. So just get all the structs and all the functions related to this and put on the headers there. But then I could see why not just copy everything because like this approach that I'm doing yeah, but it might be more annoying to copy everything because it might be like it's gonna be harder. The thing is, it's gonna be a lot harder to figure out what stuff I can delete and what stuff I can't. That's kind of the problem. So I think on the approach that I'm doing is gonna be easier to copy this stuff because I can check one thing at a time to see if I need that or not. And the other approach, I just like there's the risk that I put all these files there and then I'm gonna have to remove because they're based on other stuff. So the question is, as always, what is the middle way here? So I think I'm gonna look into this. Maybe if I press F12 here. So I have to see based on these macros here. So I think these files that have these helper functions, let's say, I think I can copy right away. The only thing that might be annoying is this macros here. But I think they're gonna be isolated from the rest. So I think this one is worth to copy. Just gonna see this thing here. So I think that Godot has the same thing. So I can change this one. It's the same thing, but it's with a different name, I think. Yeah, it's always in line, and it's the type navs. So yeah. So what I'm gonna do is just copy I'm gonna copy the path as well because I'm not really sure how much stuff I'm gonna copy from this. Hmm. It's kind of hard to decide, to be honest. This thing is kind of annoying as well. Speed through here. Because I know that is not from here. It doesn't make sense. It should be from here. This is inside of the struct and there. So it must be coming from somewhere else. Now, obviously, what I can do is just try and just see if it's gonna draw an error, but then it's gonna stop me from copying everything else. No. So source blender blown leap intern. Intern. And it's gonna be kind of annoying though. Hmm. What I'm gonna do, let me think about this. Because what I'm thinking about now is that if I copy, like it's gonna be annoying to remember which ones I copied and which ones I didn't, but it's probably not that big a deal because if I copy there, it's just gonna change the name, I think. But I am thinking about, yeah, I'm just gonna press it. I'm gonna press F10, get to the final, then I'm gonna go from the beginning again, and this time I'm going to, so once I get to the entry point there to add the Bezier curve, I'm going to close all the other windows, and then I'm gonna open sequentially one by one, and then just copy the files. I think that makes a lot more sense, to be honest. So yeah, I changed my mind. I think that makes a lot more sense because yeah, maybe I'll regret this later. The key part about this and the reason why it might be very annoying is because, as always, I think that this is what it comes down to is like there's gonna be a line that is drawn of the framework itself. So basically, what I'm trying to do is to extract from Blender all the functionality related to building the vertices to create the meshes, and then put the code related to this stuff on Godot, and then use that code on the other array mesh and the emitter mesh on Godot in order to be able to build meshes in the same way that Blender does, but using Godot instead. But the problem is that there's going to be a line there that's of the framework because obviously the whole way that Blender is set up, the structure for everything is going to be designed to work in the way that they have there, all the functionality on the GUI and stuff like that. And in Godot, it's obviously going to be different. So the question is, like, if I copy everything, then it's not going to work because there's going to be like a lot of parts of the code that doesn't make sense. But if I do it everything from scratch, I think it's not very good as well. It doesn't make a lot of sense because it's the whole thing about like trying to do everything yourself from scratch is just not fast enough, I think. And before I did this, I thought that like I was only gonna use this for the curve, but the more I think about it, the more it makes sense because I'm not 100% sure what I'm gonna build yet with Godot. So it makes a lot of sense to have functionality to be able to do more stuff than a curve. And obviously, they spend a bunch of time building Blender, so they probably figure out, like they went through all the mistakes and learned a bunch of things on how to build these meshes and these models. So I think it makes a lot more sense to use their stuff. obviously, instead of making the mistakes again. So the question here is how can I copy this stuff while how can I figure out where the line is of how to use what kind of stuff I can use and what kind of stuff I can remove, and then how do I merge the two? And this is kind of annoying because this is gonna be an object, and this is what I mean is that at some point it's gonna break down this thing. So this part might be very annoying. It might be the reason why they haven't done this yet, because it's gonna be very hard. But if I start like one step at a time, then I think it should be possible. I'm just gonna it's gonna be kind of annoying to convert this. So I have to think about a way to copy and remove in the most effective way possible. It's probably better to just. I'm not really sure. Maybe I should do what I was doing there, and then after I do that in the beginning, then I think about this. So like copy slowly only the stuff that I need there. Then I think about the rest. because the question to achieve this is how do I cut in order to be able to know uh, I'm basically trying to like trim everything from this structure and all this functionality. So I just have this stuff that is related to vertices, building the vertices from Blender, and then I put all that stuff on the other folder. And probably for all of them, it's going to be very similar. So, but in order to be able to know how to draw the line, I have to understand more like the whole pipeline. And then I'm thinking about whether or not it's worth it to like spend this time now, or if I should just implement the curve there. It's probably better, and this is what makes me think that it's probably better to just copy this stuff. To do what I was doing now, just copy the stuff that I need, then test if I maybe should build the curve, because I still need to go over the depth there. After I copy this functionality, so what I was gonna do and what I was doing now is just, I was gonna copy everything here, all the functions that are related to the whole process of the function there that gets called, like the whole sequence of functions that gets called after you click on add Bezier curve there on the GUI. So basically you just copy everything that is used to build the actual curve. And then once I have that, just go over the sequence of functions to add the depth to the curve. Then once you have all these data structures, then all I have to do is just expose that to the other class that I have, and then put the like copy the sequence. Basically, go through the stack trace of both of them, and just call the same functions and use the same structure, and then put the structure inside of the other class. So what that would allow me to do is just have the access to the vertices that they use to build the Bezier curve with the volume. I would have to change the functions as well, so that because of the points, like I need to structure in a way that it allows me to change the shape of the curve depending on the position of the points. So it's something that when I change position of the either point of the curve, then it updates the shape. So that's the next step. After I figure out how to do it from like the static thing, then it's gonna become more clear. And then what I can do is just like figure out how the vectors are being changed based on the initial position of each thing. And maybe I have to look into the other functionality as well on like what happens after you move the object, but it's probably going to be related to those matrices there that it shows in the beginning where it calculates. So what I would do is probably copy this stuff again related to the matrices, and then like this part's kind of annoying. Like either I can put the work in to try to translate the way, or just use their structs and then use the same matrices that they use to update, because all that matters obviously for the vertices is just the float values. So the values is just like a giant vector of floats. That's going to be the vectors, and that's what you use to create the array mesh on Godot. So it's basically this function here. So all that you need essentially is the verts here. The other stuff is nice to have as well, because textures and stuff like that, and there's other things about light that requires normals and indices is for optimization, but it's not necessary. The only thing that's necessary is the vertices. So like it doesn't matter which way I get the floats, because converting the floats is easy to this final vector here that's going to contain a position. And this is the one that is used there. So like if instead of having this thing here, I can just use all the other stuff like that they use, and put the functionality here, and then just create the bridge through the vector that they use to create the curve there through the vertices, and then puts on Godot's pipeline. And then the color is going to be based on the geometry. Because I think you can put color here as well. I tried to do that, but for some reason it's not working, and the geometry works, and I think it's easier. So maybe I should do that first, but so maybe that is better. But so yeah. I think I'm gonna restructure the stuff that I'm doing there. I'm gonna delete the files that I have, and I'm gonna copy the same file structures that they have, but I'm only gonna put the stuff that they use that is related to the curve. And then once I copy everything, I'm gonna delete the values. The thing is, like, I need to close the loop. I think that's probably the best way. So I'm gonna write this stuff down because it's becoming more clear to me. So now I changed my mind from what I was thinking about doing, and I think this stuff is more. So what I want to create is like a system to convert generation of vertices on Blender to godouts. Because that way I can, if I have the system, it becomes a lot easier to like. I'm gonna like is accomplishing several things at the same time. So I'm gonna become better, a lot better with Blender because I'm gonna have to study the source code and understand how it works. So in case I want to do something with Blender in the future, it becomes a lot easier. And I'm gonna have something that I can systematically put the stuff from Blender on Godot. So I think that makes a lot more sense in the long term. So the first step is close the loop on the curve. So copy uh, curve files folder structure with everything needed to create a curve. This I might have to delete the stuff straight away because obviously the object there is the first one that is obvious that I can't use the object because Godot already has an object class, and it doesn't make sense for me to use the object that they use. So stuff related to this, I'm gonna have to remove, but I think it's probably better to copy everything first and then think about what to remove. So like copy only the functionality related to the curve. Then from that part, study that part on the files that I have there. And then see, and then go back. So I'm gonna go back and forth, like generate this loop where I trim down the stuff from the other project based on the what I think is not this or what I think I can't use on the Godot's parts, because that's gonna allow me to. It's gonna make it easier to clarify. As I'm going through the source code here, it's gonna make it easier to clarify the direction that I need to go to understand the pipeline that they use here. So I think that makes a lot more sense. So copy everything, all the files related to the curve. But the problem is that it might be too much. So I think I'm just gonna copy the file structures and the functions that are necessary. So like only the stuff that is necessary from the files that they use. Then once I get to the point, then trim it down. Trim it the crowds or maybe it's better to. So before I trim, I need to test. So try to use the class, the main class, used to build the vertices as an interface on the line 3D mesh. And build the geometry from there. So yeah. So what I'm gonna do is put the create a member variable. Then after I build everything, I build another function that encapsulates stack trace from adds curve standpoint. Figure out. It's probably going to be vec3, so I think I already figured it out. But it might be different with the def. So adding the def, because the problem is, and the reason why I think is being easier than I thought so far. So like, but I think that's it's kind of deceiving because the hard part is going to be adding the depth. Because the reason why it's hard, and that I think it is hard, but maybe it's not, is that uh, the Frenet frames here. This kind of stuff is very confusing. So I'm gonna have to study this more, but it's basically a way that they use. So in 3GS they use these Frenet frames to calculate the path of the curve and put the vertices. So I think that like conceptually doing is not that hard, but to optimize it becomes very hard. So this is my concern. Because like you can think about it, so all that is happening is that you're creating a circle. So in the circle you create based on the triangles. So you're just doing calculations of the vertices based on sine and cosine. Should put the vertices on a circle, which is the thing, is similar to creating the sphere that I have there. And then obviously the only difference is that instead of creating the, like you create a cylinder. So you're just following a path, creating the circle. But the thing that I found kind of weird is that if I do it like this, then it might be, maybe it's not inefficient because it's the same vertices that you use. So like a hollow tube might be more efficient than a solid tube. But I think it's not, and I think that that's the case because like you're not gonna see inside of the tube, so it doesn't make sense to put mesh there and put data inside of the thing. That's the thing that's. So, but I think conceptually it's not that hard to understand. So you're just creating a circle and then you're using the path, the Bezier path on 3D to create a loop that takes the first circle and then follows the path along that loop. But the part that is hard is the data. So I'm not really sure which one should I. I think I should probably study. I should do the DAF as well. So I'm gonna do the true first. So before I test, I do the both creating the curve and putting the DAF, I think. And once I have all the sequence of functions, so I'm gonna both copy the functions and then write down the sequence of functions there of the select trace, because that way I can just copy and just call all the functions to change the data. And I'm gonna combine them on entry point function from the thing to generate. So basically calling all the functions sequentially to generate the first curve. Then call that function, the number variable, assigns this function here, attribute vertices and test. So yeah, it's important to test first because then it's gonna be a lot easier to remove the code that I think is not needed. Because then each thing that I remove, I can just test to see if it works. But there is the main problem is, yeah, but I think if I only do stuff that I think I need there, then it doesn't matter. So and if it doesn't work, so if it doesn't work, it's gonna fail on the other steps here, because then it's probably something that I added or something that I didn't add before that is breaking. So this is the cycle. So I can do this loop here, and then each iteration is gonna be easier. So the idea is to create a system, well, this loop. I'm probably gonna change as well again at some point to convert more classes from to convert the functionality used on Blender to Godot. I'm gonna go get some tea. I'll be right back. So the key question here, and I think what I'm gonna do, so like there isn't a way to just think uh, to figure out which way is gonna be the best. I think I'm gonna have to try. Sure. So the key question is like the frequency of this cycle that I'm talking about is gonna be determined based on the amount of data that I'm passing, obviously, because like it's a process of adding and removing data. based on what I need there. So like one end of the extreme would be to copy everything from Blender, input there, and then remove, then test to see if it works, then remove, which obviously wouldn't be great because it would be too hard to figure out. And the other extreme would be to just like put one line at a time. So like those are the two ends of the spectrum. So if you put one line at a time, it's not very effective because it's not efficient. It just takes too long to copy everything. So the question, as always, is what is the middle way between the two? And I'm thinking I'm split between the two different approaches. One is to do what I'm doing, just copy function by function, and then copy the enums, and the other one is just copy the whole files. But I'm starting to think that it's probably better to copy the files, and then probably what's going to happen is that there's going to be a bunch of warning messages, and uh, I can remove from the point, like try to remove based on the warning messages, and just get to the point where I can compile on Godot's after adding everything. Because if I do that, I think that way is probably a lot easier. It's going to depend on how hard it is to remove things, because everything's going to be coupled together. That's the problem. So like the object is the most obvious example there. There's going to have problems, but I think that's probably the best way to learn as well, because it's going to force me to think about what stuff is actually necessary and what stuff it isn't. So I think that's what I'm going to do now. I'm going to press F5, and I'm going to go back to the cycle that I have there, and I'm going to copy file by file everything that is involved into this whole process of adding the curve to the UI there. I'm going to copy, and then I'm going to see the warnings on the other project and see what they are about, and then I'm going to try to remove one by one. So like study the dependencies on the other project, and then try to remove the ones from the branches of the highest branches of the tree, that it's like try to remove the ones that don't have a bunch of things that depend on them first, and then traverse that way. Because if I'm able to do that, then I don't have to think about it. Because I'm gonna have, like, if I'm able to remove, copy the files and remove, then I can test very fast to see if it works by just getting the structure that they use there, and then I don't have to think about all the nuances. Then once I get to the point of test, then I can start the iteration going faster. So I think that makes a lot more sense. So that's what I'm gonna do. I'm just stepping over here to see like the names of everything, to see if there's anything interesting. There's all this other stuff related to the window as well. There's gonna be very annoying. So the trimming down process is gonna be hard, I think. And I think this is what it comes down to, is how much data you have. That is like how much code you have. That might depend on a bunch of other things, because that's it's gonna impact how fast you can remove. So I think the more coupled the code is, the more incentivized you are to copy less amount of things, and the less decoupled, the more you are incentivized to copy whole things, I think. So it's going to be a function of that. So it's like the structure of the code determines how, because like the way that I think about it is like code is like geometry, so the same thing. So it's like you're splitting an atom into, not splitting an atom, but like cutting a geometrical structure, like let's say, and then putting somewhere else, just like change its shape. That happens a lot on material science, I think, because like some materials change their property if you add heat or if you make them colder, stuff like that. So like it changes the geometrical structure of the thing, and then after it comes back to its original state, it's harder or like has different properties than it had before. And with code, I think it's pretty much the same. So I think that the more coupled the structure is, the more nested it is, the more you incentivize to cut like smaller parts and then build from the blocks. Because removing that's going to be hard because everything's connected. And the more fluid it is, the more the less coupling it has, the more you incentivize to copy large parts and then remove, because the code is more flexible. And I think that from what I've seen, Blender seems to be kind of is more composed than Godot, I think. So it makes more sense to copy everything, copy the files, only the files involved, and then remove. Uh, so this is probably related to the events on the like the way that they manage events, because obviously when you click there, it's going to be an event. So this is probably around the end of the cycle there. So it did everything it had to do when it comes to the logic to create the data, and now it's just dealing with the window stuff. It's very hot with this thing here, so I might stop streaming soon. It's kind of annoying me. It's really hot, so my ears. So maybe the best thing to do is just press. I think that now it's probably on the loop here. After this function is gonna continue on the eternal loop of the GUI thing. It's just gonna check the event for events and stuff like that, and draw each frame. The main question that I have is why they didn't do this before. So usually on the situations, it makes me think that like there might be some traps here and some stuff that I'm not thinking about now that's like it's gonna fuck me up, and then I'm gonna waste a bunch of time. So that's kind of why I'm hesitant to copy everything. 'Also, the other question that I just thought about is whether or not someone has done this. I guess I can look for this in this might be more efficient, because I don't see why people wouldn't do this. So what I'm thinking about is just like a library that creates only the vertices. And if I could do that, then I don't need to use Blender. So maybe it's worth searching for that now. And someone probably already has done this. I don't see why they wouldn't. So like if you have a library that creates any shape creates the vertices and normals and whatever with any the only problem is that it would have to be without using any external libraries. So this you might be challenging, but I think that it doesn't seem very challenging. For the simple shapes, I think any framework has, but for more complex shapes, I don't see why. And maybe someone already did this. So I'm gonna search for this as well. This is kind of weird to think about. Maybe just because of the way that things evolve, that it is like this. Like if you think about it, everyone could just create one library that builds anything, any shape with vertices, and then everyone uses those libraries, and everyone could use the same library. So the question is why people didn't do this yet, or maybe they did it. Because I don't think that building the vertices and other stuff is like it's not gonna change from framework to framework, because it's always gonna be floating values regardless of the thing that it is. So I'm gonna ask ChatGPT and search on search engines. The question that I have is what's so I have to think about this question. What is the best way to ask this? So are there any C++ libraries don't have dependencies with no dependencies that have algorithms to create any complex? Yeah, maybe I should have done this in the beginning. So it looks like there is libraries. The thing is like GLM I don't like because it kind of forces you to, and maybe that's the reason why they didn't do it. Like it forces you to use the same vector structure and those kinds of things. And this is the thing that I'm not looking for. Like, I don't want the object file. I want to like the algorithms that create the shapes. So this is the reason why I'm not because I also like maybe there is a way to use object files to create dynamic shapes, but that's not what I want. Like I want to be able to have the algorithm that creates the vector of floats because then it allows you if you want to change the vectors depending on like whatever you're gonna do. So I want to avoid, and then also you don't need to think about like saving and reading files and stuff like that. It becomes a lot more annoying if you put on a if you have to put on object files. Yeah, I don't think that's what I want though. So maybe there isn't any yet. I don't think that is what I need or what I want. Yeah, there's also not what I want. I think that GLM is more for like just providing the functionality to multiply matrices, vectors, stuff like that. But it's not what I want. And this is also not what I want. Yeah, I think that there like none of this stuff is what I'm talking about. But it might be reasons why it doesn't exist. I'm just not thinking about them now. Yes. The way that I'm thinking about it is like a header file, or maybe only one header. It could be several, like it could be a folder of, yeah, maybe like a folder, and then you have like a header in a C++ file for each shape, and it's just like maybe you could have you could create standard vectors and matrices on, or use GLM for the calculations, but like all that the library would do is to allow or to provide functions that based on a generic struct, for example, it creates a vector of floats that are represent any shape you want, and then you would be able to use this on anywhere. Maybe this is what I'm thinking about. I'm gonna look into this later. I'm gonna see if there are YouTube videos and then just read the documentation a little bit. Just see if it's what I'm thinking about. But it's probably not exactly what I was thinking about. So I'm just gonna continue here. What I'm gonna do is, like I said, I'm just gonna start out from the beginning and just copy the files, all the files that are involved in all the data structures and the functions used to create the curve 3D from the beginning there. Then once I have all the files on the other folder there, I'm gonna look for this stuff that I think is gonna be related to the GUI functionality and stuff that I'm not gonna be that I don't need on the other one, and also I'm not gonna be able to merge with Godot. And if I'm able to remove everything, then I will like I'm gonna create a member variable on the other class there, and then use the function that I create on that member variable to create the floats and tasks to see if the shape is created. I'm gonna go faster. It's just the event system now. Yeah, so I think this is probably on the infinite loop. Maybe not. Okay, this is the infinite loop of the whole thing probably. So it's good to know actually. So Blender Window Manager intern. I'm gonna write this down. So the shortcut stuff's probably gonna be either here. It's gonna be on one of these three here. I think it's probably similar to the way that Godot works. So on Godot they use Windows API functions to capture the events, and obviously I think it has to be like that because you're compiling for Windows. So obviously Windows is the thing that is gonna actually use the memory on the hardware and the driver for the monitor to draw the pixels on the screen. So the Windows API is the interface to the hardware. So this one probably uses functions from Windows to see if anything happened on the window. And then these other two functions, this one probably handles the events, like I said, and then this one dispatches the data probably to whatever is listening to the events. So I think either one of these functions here probably gonna have the functionality related to the shortcuts and stuff like that. So what I can do is just go to these functions and then see if I can find or put breakpoints on them to see if I can find the enums that they use to create the functionality of what's gonna happen when you press certain letters on the keyboard or when you do. Oh, I'm not sharing the screen. Yeah, these functions here that I was talking about. I'm not sure how long I didn't show the screen, but I think I wasn't showing anything before this. Just talking about some looking this stuff here. So I think now it's already. So these are the two functions I was talking about that are probably this one is probably related to Windows APIs to get events with Windows, and the other ones are for there's probably going to be an enum or something like that that is used to create the functionality of what's going to happen when you press some certain words on the keyboard and stuff like that. But I'm not going to spend too much time on this now. So I think, yeah, it's over. So I'm going to delete this. And then I'm going to go through the cycle again. I'm just going to copy the files from here. So it's editors curve. Honestly, I think I'm gonna do this off stream because it's better to use the two different monitors to do it. It's probably better if I close this stuff. Gonna be on editors. Yeah, I'm gonna go over with the F10 through the whole cycle again to just have an overview, and then I'm gonna copy the files off stream because it's gonna be easier to use the two different monitors to see the paths and stuff like that. What I'm gonna try to do first is to just copy everything, and then if I see that it's too slow because there's so many things, because what I'm gonna have to do is like each one of these files are gonna have a bunch of data structures related to stuff, other stuff, and my concern is that I'm gonna have to end up copying every file, which is the similar process that I went through with 3PP. So I'm just trying to do everything from scratch, and yeah, I have to reflect on that thing, and then, but I think that, yeah. I do think that I could be faster there than I was. But I don't remember exactly. I think that on the 3PP stuff, what it took me the most amount of time was to restructure the things the way that they did. So that's kind of the thing. But it was pretty much the same. It was very similar. I just copied the files as well, and then I changed a couple of things. Yeah, so maybe it is a mistake to copy the whole file. Because I think that the conclusion that I got through after the 3PP stuff is that like, if I had started, but the problem is obviously you like at the time that I started, I didn't know what I know now, so I had to go through the thing to learn this stuff. But what I was thinking is that like if I started from the beginning with the thing that I had in mind, or not the thing that I have in mind, but like if I knew the stuff that I know now when I started, and I didn't copy stuff, I just did it with the way that I was thinking about, it would be a lot faster. But this is kind of the problem because in order to be able to do that, you have to know. So it's kind of like a paradox. So But I do think that like the most important thing out of that was to like clarify the process behind it and then just do from scratch, let's say. So the question is like, how should I do this here? Because obviously I don't want to repeat the same. It wasn't really a mistake. I don't see it as a mistake. It's just that I could be faster, I think. That's what I'm trying to think about now. I do think it's worth spending time on this because like it's a systematic thing. This probably is gonna happen everywhere. So if I can figure out, like, ideally each time that you go through the cycle, you should think about how to optimize the next time. I think that makes a lot of sense. Yeah, so I think probably copying everything is a mistake. Like copying the whole file is a mistake. So I should copy the functions. Yeah, copy the yeah. So I think that's probably better. But the issue is that there's gonna be like it's gonna be fundamentally different. It's pretty much the same thing from 3PP. Like the thing that I'm trying to achieve is gonna be different, and what it matters is to clarify the process of what's needed to build the curve. So what are exactly the algorithms that are needed? So I'm gonna go over one step over fast now on stream, and then what I'm gonna do is just copy. I'm gonna copy the files, but from the files, I'm just gonna copy the functions. So follow the stack trace, and then copy the structs and the enums that the functions use. Then from that point, I'm gonna remove straight away, I think. So it's probably better to remove first, and then because I think that the main thing that I need is the vectors. So I need the functionality related to vectors and remove everything else. So that makes more sense. So like instead of doing the whole big cycle that I was thinking about, copy the whole file, it makes more sense to copy just the functions that I'm gonna use and then the enums and stuff like that, and then remove right away and just focus on the actual thing that I'm gonna need on the other one. So that's what I'm gonna try to do. But I'm gonna do this off stream because I think it's gonna be better. So all this stuff related to layers, I don't think I'm gonna need. This creates the object. Probably allocates memory here. It's locking the thread probably. Yeah, locking threads. Uh, so up until now, like all this stuff I'm not gonna need, I think. So this stuff related to the objects also I don't need because this stuff is related to the functionality of the whole thing that they have there. But it is easier than I thought it would be, to be honest. Like, I hope actually, because obviously I didn't do it, but based on what I've seen here, it seems that it's gonna be easier than I thought it would be. So I think that the key thing here, maybe it is worth it to spend more time watching videos and studying. The thing is, I already watched most of the videos about the source code. And the other videos about the GUI is probably not gonna help that much for what I'm trying to do. But I do think that I should probably spend more time because I think that the core thing here, in the way that it works, is gonna be the DNA and RNA things. And those are the essential things that create the objects. Also, like the last video, he talks about the kernel here. So probably maybe the kernel as well. Like, do you remember a guy saying that the kernel is the thing that contains the all the functionality or something like that, or most of the functionality. So I think that the key is to clarify the files and folders that are used to manipulate the data first. So clarify that. So maybe I should spend time on the layout here. So if I have a decent idea of all the places that are used to create the data for the vertices, then it becomes a lot easier to transfer the stuff. So maybe it is worth it to go through the pipeline a couple of times to clarify the whole process. Because the thing is, I still need to look at the other one, so I have to look into both of them. So both the whole like all the functions that are used to create the shape in the first place, and then the function I have to look more into the flows of what happens after you add the geometry for the first place and when you're manipulating the geometry and all the files that are related to manipulating the geometry. I think that's what matters. Then once I have a clear picture of the structure of the files that are used to like manipulate the object in general, the shape, and create the vertices, then I think I can copy because it's gonna be more effective. But still gonna do the same thing that I said. Just copy the functions related to the whole flow of things, and then remove the stuff that I think is not necessary, and then just keep going until I can test, and then once I test, just continue the feedback loop system. So yeah, I'm gonna press F10 on everything, and I'm gonna get to the point. So where it has the curve there, and then I'm gonna see. I believe I put breakpoints. I'm gonna search first. So search first based on the tooltips that are on the DAP. So if I remember correctly, it's gonna be on the data parts on the icon there. And it's gonna be on geometry, and it's gonna be on bevel, I think, bevel, and then depth. That's the stuff that I'm interested on, the attributes of the curve. That's probably I should spend more time on that part because I think that part is the hardest. So all this stuff here so far is just to build the path of the curve first, and then the other stuff is probably the one that is going to be more complicated, which is the one that builds the depth on the path. So what I want to clarify is like how to combine the two. This is the part that I think is going to be hard or the hardest. So maybe it seems kind of easy now because I didn't get to that part yet. I'm just gonna press stuff down on everything. So here is the first point that is going to build there, I think. This is the function that I was copying there, is the entry point. That actually builds the data for the first time. And this stuff here. So everything else I can trim it down, I think. I should probably start from this point, like I was doing there before. So I'm probably not gonna remove what I have there, but I'm just gonna change the path to reflect whatever's happening here. And that's what I'm gonna do. And then I have to see the other stuff. I don't understand why they use all these linked lists here. think I'm just gonna like keep this same because those parts are very annoying to translate the information here. So I'm gonna try to keep the same. Like use this the structs that they use and the functions that they use to calculate the stuff. So I don't have to think about how to translate this kind of stuff to Godot because I think that is like a micro optimization kind of thing. So obviously like not an optimization, but like in the same style, same line of thinking where it's not worth it to spend a bunch of time like dealing with these problems because it makes more sense to build on top of the things. But these are like another like paradox or those kinds of things because if you always do that, then it becomes a spaghetti eventually. So maybe it's better to just switch things there. But yeah, not really. I don't think it matters that much. I might be wrong about this, but I'll see. Even if it does matter, I think that it makes more sense after you test and you have the thing, then you think about this. Yeah, because then it becomes a lot easier also to translate. So because then obviously you can test, just change one of the functions and the data types and then test to see if it works. So I think right now is not worth it to think about this. This animated stuff is kind of interesting as well, but it's probably not gonna worth. It's not gonna be worth to spend much time. It makes more sense because I think these parts I'm gonna have to use Godot and stuff, so it makes more sense to do the whole physics and movements of things from Godot's point of view, and then just use the same functions for building the vertices and just change the entry points that interact with the functions. But maybe at some point I will look into this just to learn how they do things. How do they animate the stuff? Skip this. Here I think it's already the point where the main function there is the one that I was copying, is this function here. I think this is the main function that I need to translate there. Is the one that is gonna build the first shape of the curve. And then after here is already after is going to just deal with the rest of the event loop thing there. So I'm gonna press F5 and I'm gonna search for the point here. So yeah, I think was on the data and then geometry and bevel. This is the stuff here. So I'm pretty sure I put the breakpoint, but I'm gonna do it again or see it again. Pretty sure I put this. So it is here, but for some reason it's not working. Executable code of the debugger's target colon type. Hmm. Interesting. So it's basically saying that the target that I compiled for doesn't have the code for this breakpoint here. So the only thing that makes sense is that obviously this, because the thing has the description there. So at a certain point should be creating that description. So maybe, yeah, so it's through here, probably. But the thing is that this is just gonna be, so I'm gonna see if I can search for the other stuff. Because this is just related to the functionality of creating the display. I think it's not gonna be what happens after, but the reason why I didn't search for DAF is that it's unlikely that I'm gonna find anything. Maybe Bevel is more likely. Because there's probably gonna be a bunch of stuff. Oh, is the issue. So Bevel, I think I can look for the other stuff here. Object data properties. What I'm trying to clarify, what is the relationship, is what the relationship between the overall thing that it creates here, the Bezier curve, and these categories here. So like how they connect with each other. Oh, they use non-SVG. Interesting. The problem is like here is gonna be for all the objects, so this is kind of the annoying thing. So I have to think about a different way. I guess like this is the reason why it's hard, because Now obviously like, this is a placeholder that's gonna work for any object that it has there. So it's gonna change. You know, like the question is like how do I find the breakpoint that is gonna be related to the curve that is gonna have these properties here. And so I know that the like, so the overall thing should be a curve. Is the structure of the curve there, I think. So it should be obviously connected with the curve. I guess I can look for from here. So yes, but I'm gonna try to look for the icons like each. Yeah, but the problem is it's gonna be based on the enums there, so it's like not necessarily related to the. I'm trying to find the thing that is used to update the data that the GUI is referring to. It's probably gonna be this thing here. But so the question is, how does this thing change the values of the thing? Maybe this function. So I do think that the prop has something to do with this. I do remember going over this. I think was yesterday. Something related to this. So maybe we should look into the folder that has this stuff. RNA curve. Hmm. Yeah, but this is the spots that it says that it wasn't compiled here. Hmm. Oh, this is the issue. So I think that probably what is going on is that like Blender compiled this code as a library or something like that, or dynamic linked library or something like that. So I think one way to go about this is just doing reviewing the build system. But if I could, because the problem is that I do think that like this is how it works here. It's just gonna be he's gonna use the same struct that he has there for loading the information for each object, and then the way that he's gonna update the object is gonna depend on what kind of thing it is. So maybe if I put the breakpoints on these functions, is gonna be. But I have to find one that's like the closest one that I can put the breakpoint on. So maybe if I put the breakpoint here, is gonna or one of these functions is gonna stop there when I change the value. It doesn't change it. It doesn't break anything. So this is the issue, is that let me look for the other values here. Click on this. Oh, so this is related to other stuff. Yeah, so all of these are probably the structs there. So remember that there is a scene struct. So this is probably the object that shows there in the beginning. So when it's creating object data and stuff like that. Hmm. Trying to find the object because I think it's gonna be just see what kind of file I can search for there. Here. So just like the other ones, I think that the data part here there is gonna be a struct. And I'm trying to figure out how like what function I can put a breakpoint so that it stops there when I change one of the values. So it's on makes DNA. It doesn't have data. What is if I so maybe you can search for other stuff here. The thing is, if I get the struct, there's not based on the way that other stuff works. There isn't gonna be there aren't gonna be functions inside of the struct that determine what happens. It's based because it's more a composition approach. It's gonna be based on the other stuff. So this is kind of the problem. Like the functions that are used are gonna be dependent on the same generic structs, let's say. And the only way to know which ones are used is gonna be on the runtime, but then I can put breakpoints if I don't know. So I'm trying to find one function that allows me to put the breakpoint so that it stops when I change the value there. Because then I can look into the values on the debugger. Can I put here? No. I guess all this stuff that is inside of the intern is probably going to be compiled in a different way, so I can put the breakpoints there. But I think it's gonna be related to this. So it's gonna change the value of the props here. Yeah, so it's defining the properties of the curve. So it's probably gonna be on the curve. So it's both the property RNA, the struct RNA, and it's gonna be on the curve thing. So the curve is probably the struct that has the bevel stuff. Geometry bevel. So let me see from the curve. I think I have. Pointer to curve data from evaluation owned by the object's geometry set eval. There as a geometry instance store the data of the evaluated curve component. Curve may also contain data in the NURB list, but for evaluated curves this is the proper place to retrieve data, since it also contains the result of geometry nodes evaluation and isn't just a copy of the original object there. Yeah, but it is another curve. So, yeah. So it is inside of the curve. So they use another struct here. Also, geometry is this one. So it's probably going to be a value here. It's going to be the bevel value inside of this thing here. So the question is, how do I use this? Yeah, so I guess I can go again from the other points to see how they name the curve. How do they initialize the curve? But I think it's going to be inside of the NURB object there. Yeah, it's going to be kind of hard to find based on that route. So maybe I can search for this stuff here. Like the names here. There isn't anything about bevel there. I do think that this struct here is the one responsible, the one that shows here. And the overall thing here is the geometry there, or the curves. So, so it has animation data and geometry. It might be different names. So this is probably the thing. So it's another object. When set, the curves will have attributes that indicate the position of the surface. is used for deforming the curves when the surface is deformed dynamically. This is expected to be a mesh object. So yeah, I think it's probably is pretty much the same. So Godot has a line 2D and they implement it the same way. So the way that they do it is by like you and there's different ways you can do this as well on 3D. You can use SCG polygon. So you basically use two different nodes. One node or class is going to be the one that creates the path, and then that class is used on another one that creates the shape, the geometry. So I think that's pretty much what's happening here. So the curves is going to be the one that has the path, or the curve has the path, which has the curves. There's some relationship like that, and then the objects here is going to be the actual mesh, which is going to give the shape to the curve. But it's kind of hard. I'm trying to figure out a way to find the function that is going to be called once you change the values there. It's kind of hard to find based on this stuff because I think it's just going to be the same types. So if I look for the types here on the code, it's not going to allow me to see because it depends on the runtime. And it's probably going to be depending on what object it is. Hmm. So how do I find the entry points of what happens after you click there? Yeah, I think whatever shows up here depends on the selection here. So like for each one, there's going to be different stuff. So this shows the object, and then each object has different data. Yeah. So obviously they are related. So the curve there, I think, is going to be the one that I was seeing before, is the curve struct, this one. So I guess another thing that I can do is just look for the other flows. So maybe if I add something else here, it's gonna break there. But the thing is, I don't remember if I put the breakpoints for the other stuff. Yeah. Okay. So yeah, I think I'm gonna stop streaming here now. But this what I'm gonna do now is just go over a couple of them. I think maybe just one or two. So I'm gonna go enough over this cycle here of adding objects because what I'm trying to figure out is the connection of the object that it creates. Because I think all the objects are gonna be basically the same way. So you're gonna have this object struct here. This object struct's gonna have the edit value, I think, inside. And then at some point it's gonna create based on the type of the object it is. It's gonna create a different struct, and then that struct is the one that is related to the actual object that you're creating. So in the first case that I was watching is going to be the curve struct. And so this is the first part. So one of this, like those structs, either the object struct or the struct that is created by the object, which in the curve case is the curve struct, is going to contain a member variable that is related to the data. And the data is the stuff that is displayed there on the bottom. So I think that's how they design things. Like is in both situations is like a generic thing. And the main thing is like you always have the object and the data, and then you compose them together. And then the values of each one is going to depend on the thing that connects them, which is the actual struct that you're creating, which is the member variable of the object. And then there's some relationship with the data that I'm not really sure what is. So what I'm trying to figure out is what are the functions involved after you select the object to change the data of the object, to change its shape. Then once I figure that out, I'm going to put breakpoints on those functions. And then I'm going to start analyzing what happens, or the flow of execution of what happens after you change the depth of the curve, to try to extract the functions that are gonna build the vertices to build the 3D curve. So once I do that, and I have those two parts of the cycle, let's say, then what I'm gonna do is just gonna copy all the functions related, functions and files related to the whole process of creating the curve and adding the depth. Then once I have those files on the Blender folder on the Godot project, what I'm gonna do, I'm gonna, like I said, just try to copy only the functions that are used and the data structures that are used to create the curve 3D and add the depth and remove everything else. So once I do that, I'm going to try to use the struct as an interface on the other class that I have, which is the line 3D mesh that I'm creating. And I'm going to make a member variable on that class that is going to use the functionality that I put here on the Blender stuff to create a function on that struct. So I'm going to add a new function probably on the struct that they put there that is going to put all the flow of execution of functions together in one function to create the whole process after I call the function. Then once I have that, and also the function is going to return a vector of floats probably, or a vector of vector 3. That is the data structure that Godot uses there. Once I have that, then I can test. I can call that function from the loop. So basically on Godot, the way that it works is on the array mesh, and I think the emitter mesh is the same, but I just tested with the array mesh and it is working now. And it's basically this, all you have to do is just create a class that inherits from array mesh, and then you, in this case I created this function here, so you basically build the points, and then you update the value of this thing here. And then the main function that is going to be used from array mesh is this function here. That's going to use whatever values you put here. It's basically an array of arrays. So it's mapping based on the enums, what kind of vectors it is. And these values are vectors of vector 3 or vector of floats, or something like that. Depends on which one, I think. And these are basically going to be the properties that are used to render the, to eventually send these vertices to the GPU, or to buffers that the GPU is going to use to draw on the shader pipeline, the rendering pipeline, to draw the object. So this is the main function, basically. So what I'm going to do is just replace these values here. I'm probably going to create another function to not mess up this one, and just do the same thing that I'm doing here. So instead of building the vertices like this, I'm just going to call the function from the struct that I'm going to create on the Blender folder there, and then build the vertices that way, and pass here, and then test to see if it's going to create the 3D line on Godot. If I get to the point, then it works. Then what I'm going to do is just the process that I talked about. So go back to the Blender code and see if I can remove more things. And then each thing that I remove, I'm going to test to see if it still works, the curve. And I'm also going to have to change the function so that it depends on the two final points that I give. So the idea that I have is just pass like the beginning point and the end point, and another optional variable that is the control points in the middle. And then basically do what Blender does, but programmatically, of creating the curve based on the control points and then giving the shape. And then building the vertices based on that with the depth that you pass, that is probably going to be dependent on the radius that you pass through the line 3D mesh. That's the idea. So yeah, what I'm going to do now after I stop streaming is just continue the flow here. Then do what I said, and probably next time I'm gonna still be doing this, so maybe I'll stream tomorrow or whatever. I'm gonna still continue to try to do this stuff here, so see you next time.